Good morning. Today our group are going to present about the assignment for analog electronics BEJ 10503 or BEV 10503 for SEM 2 2021 and 2022. Our group is group 5 and our group members is Hong Pentat AE 210060, Lim Liang Hui 2 AE 210058, TNU AE 210055, and our lecturer is Dr. Nomiza Binti Oman. Introduction. Bipolar junction transistor BJT and the field effect transistor FET are the two basic transistor types. Transistor is a three-terminal device whose output is current, voltage, or power. The BJT and FET amplifiers were assumed to be operating in the mid-frequency range, which is reactance of all bypass and coupling capacitors are considered to be zero and replaced by a short circuit, whereas the effect of capacitance in the transistor are negligible. Transconductance GM and GMO, which is an electrical characteristic relating the current through the output of the device to the voltage across the input of device.
Now we learn about calculation and result part. For the question A, we're using the Schottky equation to determine the ID if make VGS as a constant value. First, when the VGS equal to negative 4 volt, the ID will become 0. When the VGS equal to negative 3 voltage, the ID will become 0.5 milliampere. When the VGS equal to negative 2 voltage, the ID will become 2 milliampere. When VGS equal to negative 1 volt, the ID will become 4.5 milliampere. When the VGS equal to 0 volt, the ID will become 8 milliampere. And next equation is VGS equal to VG minus VS. We multiply it and simplify it will become 1.982 minus 1.2K times ID. Then we let the ID become 0 volt, the VGS equal to 1.928 volt. Next, we let the ID equal to 4 milliampere, the VGS equal to negative 2.818 volt. Next, the volt and the graph of the ID against the VGS, the curved line is a Schottky equation, and the straight line is a VGS minus equal to VG minus VS. Then the point is a Q point. The Q point is negative 1.57 and 2.98. For the transconductor, GM naught equal to 2 IDLS over modulus VT equal to 4 ms. For the transconductor, GM equal to GM naught open bracket 1 minus VGSQ over VP close bracket. Then we substitute and calculate out the GM equal to 2.43 ms. For the question B, the higher cutoff frequency of input network FHI is equal to 1 over 2 pi times RH input times C input. Then we substitute, manipulate, and calculate out the answer is equal to 0.641 MHz, and the high cutoff frequency of output network FH output is equal to 1 over 2 pi times RH output times C out. Then we substitute, multiply, and calculate out the answer is equal to 4.62 MHz. Hence, the dominant high cutoff frequency is equal to the lowest value of the high cut frequency. This is also same as the higher cutoff frequency of the input network FHI is equal to 0.61 MHz. For the question C, the lower cutoff frequency of coupling CG capacitor FLC is equal to 1 over 2 pi bracket R signal plus RI bracket times CG. We substitute and multiply and calculate out the answer is 1.46 Hz. And for the lower cut frequency of the coupling CC capacitor FLC also equal to 1.2 pi open bracket RO plus RL close bracket CC. We substitute, multiply, and calculate the answer is equal to 21.65 Hz. For the lowest cut frequency of bias CS capacitor, FLX is equal to 1 over 2 pi R equation times CS, and we substitute, multiply, calculate. We find out the answer is 236.1 Hz, and the domain cutoff frequency is the highest value of the lower cutoff frequency, also same as the lower cutoff frequency by bias CS capacitor FLS is equal to value 236.1 Hz. Thank you.
Analysis. In question A, the Shockley's equation method and VGS equal to VG minus VS equation was being used to obtain the transconductance GM and GMO. Then plot the graph to find the point Q. By obtaining the coordinates of point Q is equal to negative 1.57 and 2.98, then the value of IDQ equal to 2.98 mega ampere and VGSQ equal to negative 1.57 volt. So by using the information just now, calculate the GM and GMO by using the formula. Then we will get the result that GM equal to 4 millisiemens, while the GMO equal to 2.43 millisiemens. In question B, the high cut-off frequency of input network equation FHIE equal to 1 over 2 pi RTHI CI, and this result is 640.7 kilohertz. The high cut-off frequency of output network equation FHO equal to 1 over 2 pi RTHO CO. Then this result is equal to 4.62 megahertz. Therefore, the dominant high cut-off frequency is the same as the lowest value of the high cut-off frequency. In the question C, the low cut-off frequency of coupling CG capacitor equation FLS equal to 1 over 2 pi R plus Ri times CG and equal to 1.46 Hz, while the low cut-off frequency of the bypass CS capacitor equation FLS equal to 1 over 2 pi REQ CS. The calculated answer is equal to 236.1 Hz. So the dominant cut-off frequency is the same as the highest value of the low cut-off frequency.
Discussion for question A. By using the Schottky equation and VGS equal VG minus VS equation, we can know that the value of IEQ is a positive value, while the value of VGSQ is a negative value. The cutoff frequency for a high-pass filter is about of the frequency for output voltage, also known as load voltage is equal 70.7% for the input voltage, also known as source voltage. The low cutoff frequency for bypass capacitor cause reduced gains at low frequency and have a high pass filter response, making the value of the frequency is higher. In addition, the value of coupling CG capacitor is the lower because the SC is increased and drop the signal voltage across the capacitor and reducing the circular gains. As signal frequency decrease, capacitor reactance increase and gains continue to fall, reducing the output voltage. In conclusion, from this assignment, we can learn about the Schottky equation and VGS equal VG minus VS equation. We can know that the value of the high cut-off frequency of the output network is lower than the value of the high cut-off frequency of the input network. Lastly, from question C, we can conclude that the value of low cut-off frequency of coupling CG capacitor is the lower frequency, while the low cut-off frequency of coupling CC capacitor are the second lower of the low cut-off frequency. Lastly, the highest low cut-off frequency is bypass CS capacitor. Hence, from this assignment, we can learn how to analyze compound configurations and frequency response of analog circuit. Thank you.